There are many science experiment videos on YouTube using light, magnets, and more, but I recently found a shocking one. This video, when you place a phone and call, that wire mesh thing starts to burn. Wow. I couldn't believe it. Hi, this is Chanu from Geekbo. Smartphones use radio waves to communicate, which are invisible but always present. I was amazed to learn that they can ignite steel wool. So today, we're going to test if calling a phone can actually set steel wool on fire. Here's some steel wool that I brought. I'm going to shape it into a circle. Ouch! Oh, I'm bleeding. I'm not doing it. Anyway, I made the steel wool into a circle like this. Now if I place the phone on it and call, let's see. I forgot the call. I'll ask for help.
Hello.
Hello. Hey, Cookie.
What's up?
He'll call. The call's coming in, but there's no reaction like burning or sudden heating as in the video. Some might feel uneasy because this steel wool is different. It's thicker, so I got another set.
Wow.
These are the steel wools from the video experiment. They're much thinner and fluffier, looking more flammable. Let's see if this one catches fire with a call. Now, I'll place the phone. It's a rare material. Many might be seeing it for the first time. It doesn't heat up. So how did they ignite in the video? The hidden process. With just this battery, a trick. By touching both terminals on the steel wool, just lightly, now it ignites. Burning, amazing. Let's try in here. Wham, hot.
Smell.
Oh.
Movie effect. Yeah, it really bangs.
Whoa.
Wow.
Oh.
What if extinguished?
Whoa.
Ow.
Whoa.
Straight from hell. Phone thumbnail. In summary, the video was fake. The burn was staged. Phones use radio waves, but can't ignite steel wool.
Oh my god!
Electromagnetic waves, but it requires a brief explanation. When discussing science, a science cookie is perfect. It simplifies science, so students love it. Today, let's try an experiment with it.
Hi. So, the steel wool here can actually burn. There are various kinds of electromagnetic waves. The light you're seeing me is one type, and there are radio waves used in phones. When we go to the hospital for X-rays or CT scans, REX are also a type of electromagnetic wave. There are things like wavelength and frequency. For example, when playing piano, there are keys from low to high notes. When we hear these sounds, we hear do, re, mi, fa, sol, la, si, do, due to different wavelengths. Microwaves can cause steel wool to burn, like in the video.
Really?
Shall we try it?
You try it?
What you need is a microwave.
A microwave?
Got a microwave.
Yes, we do.
If you put this in the microwave, it's really simple. Never try this. Big warning!
The Don't try it.
3, 2, 1. Start.
Uh,
Pretty intense, isn't it?
wow, it's sparking.
Right?
I was surprised.
Right? Fascinating. I knew it theoretically. First time trying it, I was surprised.
Oh, really? We saw microwaves.
Right. Can't we check similar waves to confirm that you'd need a detector for electromagnetic waves? Our eyes are detectors for light, for X-rays. A film would be the detector.
Why don't we ask one of our makers if we can make a detector?
Is this how show works? For sure.
We're just asking.
Ah, right. Who to ask?
Probably should ask Minbeck about this.
We can't actually see radio waves with our eyes, right?
Oh, so
If we asked, they said they could do it. Can you make a device to see radio waves with eyes?
it's just that electromagnetic induction, when fields change near conductors, currents flow.
Right?
You can read that. Shouldn't take long.
Really?
Oh,
I
really?
think we can do it quickly,
Then that's cool.
but since it's done on the spot, it won't be made very nicely. Made in Rust,
Wow, you made it instantly?
Can we figure this out?
so if it detects electromagnetic waves, this LED will light up more. Looking here, since it's close to the light, there are more waves than I thought.
Ah, but the phone isn't reacting much.
Due to strength. It's amazing how it receives such faint waves that they hardly even register.
Yes.
Shall we try the microwave?
Microwave. The front doesn't detect well.
Maybe it will from the back line if it does. Oh.
Oh, it works? Wow.
Wow, look at this. Isn't it amazing?
Wow, amazing! Wow. Wow.
It's really powerful.
It's blinking already.
Right?
There's visible
Exactly.
light
Yes.
microwaves
Indeed.
and radio
Indeed.
waves. What specific types of electromagnetic
think
waves
about it?
do we typically use?
It's fascinating.
30, 45G.
That's about 3G, 4G, 5G as communication generations. 4G is the 4th generation. And this time, it will be the 5th generation. The frequency range they use is called a frequency band, which can be likened to a path for transmitting information. Which path will we take? Some are narrow like canyons, others like highways. Well, with 5G, since it uses a new frequency band, the path width red can be wider, which means more data can be transmitted in the same time, essentially making it faster. The biggest advantage of 5G is that it can use millimeter waves that 3G and 4G couldn't technically use.
Millimeter waves. Millimeter,
Yes,
like the ones
millimeter
we
waves.
know.
The length electromagnetic waves travel per vibration is in millimeters.
Is it fast? Very fast. Those waves, usable from 5G.
Yes, but why couldn't we use it before? It's simple. All waves have diffraction. High frequency means less diffraction, so they don't spread well against obstacles. But tiny antennas for millimeter waves made a tech revolution.
In the past, millimeter waves couldn't be detected well due to low diffraction.
Exactly.
Now, tech lets us detect them.
Exactly. We can now use it more efficiently. It's a 5G revolution. We're using sub 6 gigahertz, lower than 20 gigahertz, but 28 gigahertz offers 8 times the bandwidth,
Within 5G, an 8-fold bandwidth difference.
right? Using 28 gigahertz with millimeter waves offers much faster speeds in 5G. This means features like real-time translation or AR games, things from sci-fi, will be seamless. I'm excited. I'm excited because to be faster than wired internet. Wireless might pass wired soon. Domestic wired soon. Domestic telecoms have the 28 gigahertz frequency and plan to commercialize it this year, but they aren't aggressive yet. The US has millimeter wave smartphones, and other countries are planning, but our country seems hesitant.
Telecom should adopt millimeter waves and release smartphones soon. How do you know so much about 5G?
Many of our Science Cookie subscribers have been asking for 5G content.
Oh, really?
I researched it. It's difficult. If any of you are curious about what 5G is really
5G?
about, or want to see it neatly summarized with hand-drawn illustrations, you can head over to...
The Science Cookie channel?
Please check out the videos.
Geekbot.
Do we have to do
Can
it like
you-
this?
That's correct.
Kickba.
2. Geekbot.
Kickba.
Ouch.
Oh, shoot.
Oh.
It's burning.